Okay, it's been a while since I've visited you at home or in the atrium or on the bus or in the car or wherever you might be on your phone watching this amazing video. But I'm glad to come back to you live from Brent International School. And we're talking scientific notation and standard notation. These numbers here, standard notation. When I talked about, hey, you got to write the number in decimal form, that's standard notation. This over here is scientific notation. The key in scientific notation, two things. First factor, this first number here, has to be between 1 and 10. You might want to highlight that. Between 1 and 10. 4.3, between 1 and 10. 43, not between 1 and 10. It can't be the first factor. 0.43, not between 1 and 10, can't be the first factor. It has to be between 1 and 10. And then the second factor is just a power of 10. That's why we've been doing so much with powers of 10. Now, we are going to look at the exponent here in the power of 10. If it's a positive integer, positive exponent, it means it's a large number. It's a huge number. Remember, scientific notation is to represent big numbers and really small numbers. So, positive integer, large number, negative integer for small number. Okay, and we're going to work over the next couple days changing scientific notation to standard notation to scientific notation. And it's a fairly easy process once you get into it. So here are some instructions how to convert. You can read those on your own, but I'm going to go right here. So these are the steps to convert. This is number 1. Don't get confused. This is number 1. Okay. You want to ask yourself, is the exponent positive or negative? Well, this exponent is positive. So I'm going to put positive there. And it's really hard to write on this screen, but I did it. Positive. Okay? And now, because it's positive, we know the number is going to be a large number. To make this a large number, we have to move the decimal to the right. We got to go to the right. So we're going to move it to the right. Positive exponent means move to the right. And to determine how many places, you just look at the exponent. It's 6. So I'm going to move the decimal to the right 6 places. Well, what does that mean? That means I start with this, 4.2. And then I take this decimal point and I move it 1, 2, 3, 4, 5, 6 places to the right. And now this is my new number. I fill these in with zeros. 1, 2, 3. I'm going to put a comma there. 1, 2, 3, comma there. So this number, 4.12 times 10 to the 6, really equals 4,200,000. So this is much easier to work with than this big number, especially when you get even larger. Imagine if that exponent was 26. I'd have all these zeros, 25 zeros at the end. I would hate to write that. So that is why we write scientific notation. We don't want to write these huge long numbers with tons of zeros at the end. So for number 2, 3.4 times 10, and this should be a negative sign. It's hard to see the negative signs here, but that's a negative 5. So do I move it to the right or left? Well, negative integer is a small number, which means I got to move it to the left. So this is negative. I'm going to try to write negative. Whoa, look at that. Negative, and that means I'm going to move it to the left. How many places to the left? I just move it 5 places. That exponent tells me how many places. So how does that work? I start with the original number. Notice I started over here to the right because I know I'm moving to the left. Tricky. So that's 1 place. That's 2 places. 3 places. 4 places. 5 places. There's my decimal. I fill all of these in with zeros. Boom. And I like to add a 0 out in front just because I do. So this number, 3.4 times 10 to the negative 5th, is equal to that. Because remember, 10 to the negative 5th is 1 over 10 to the 5th, which you guys learned last lesson is really equal to 0.00001. So I'm multiplying 3.4 times 0.0001, and this is what it ends up being. Okay, so that's how you go from scientific notation to standard notation. Hope you enjoyed. We're going to move on to the next one. Please do these practice problems on your own, those 3 practice problems. And number 4, this is a negative number. Okay, that's a negative 4. All right, moving on. Now we want to go from standard notation to scientific notation. We're going the other way because these numbers here are way too big to work with. So how do I do it? Well, to convert to scientific notation, determine the factor between 1 and 10. Remember, the lead factor has to be between 1 and 10. Then determine the power of 10 by counting from the decimal point in the first factor to the decimal point in the given number. Sounds complicated, really not. I'm going to change this. I need the first factor. I know it has to be between 1 and 10, so I'm going to just put 3.2. That number is between 1 and 10. Easy enough. And then I ask myself, from that location, this one right here, from that location, which way must the decimal move to its location in this number? Well, I got to move it to the right. Okay? And how many places to the right? Well, there's 1, 2, 3, 4, 5, 6, 7 places. I think, and let me make sure. 1, 2, 3, 4, 5, 6, yes. I always like to double check. And then I write the number in scientific notation by doing this. I write my lead factor, 3.2. It's between 1 and 10. I put my multiply sign, times 10. I know it has to be a power of 10 to the 7th power. Okay, that's all you have to do. So I do the same thing over here. I change this number to a number between 1 and 10. I put the decimal between the 7 and the 1. And now I have 7 and 12 hundredths. That's between 1 and 10. Then I ask myself, do I have to move it right or left? I have to go left to get to the original decimal. It's a small number, so I know it's going to be negative. Okay, how many places? Let me count. 1, 2, 3, 4, 5, 6, 7, 8 places this time. Let me check again. 1, 2, 3, 4, 5, 6, 7, 8 places. So I write my lead factor, 7 and 12 hundredths times 10. Because I'm moving it to the left, because it's a really small number, I know it's going to be a negative exponent, negative 8. And there you have it, folks. Going from standard notation to scientific notation to standard notation. Please complete these 3 in your notebooks. I hope this was helpful. What I want you to think about is, how big is 10 to the, let's say, 24th power? Like in our universe, what is it? And how small is, let's just say, 10 to the negative, let's just say negative 10th power. How small would that be? What does that represent in our universe? And that is what we are going to look at next class. Thanks for tuning in. I said 5 minutes. It's 8 minutes and 24 seconds. Sorry to keep you 3 minutes overboard. I'm going to head to the Christmas concert right now. Hope to see you all there. And goodbye.